Okay, so we're going to be factoring trinomials. We're going to start with this example. And so I laid out x squared plus 7x plus 6. So the way that this works is you start with the x squared, and then you arrange the c term. Oh, wait, I have 7. Okay, you arrange your c term down at the bottom. All right, and so let me see if this works. Does it work for me to place these? Because my goal is to make a rectangle. Well, I have a problem, right? That would be, this is showing me that x plus 3 and x plus 2 multiplied would give me x squared plus 5x plus 6. That's not what I have, though. I have 7x. Right? So that tells me this doesn't work. So then I have to try to make some other arrangement. Okay, so since 2 and 3 don't work, how about 6 and 1? And that is going to work. Okay, so I can see that this factors into x plus 6. Right, here's my x plus 6, and then the other direction, x plus 1. Okay, so let's move on to x squared plus 2x minus 15. So here's minus 15. Okay, and so again, I have to make a rectangle. And 15 and 1 and 3 and 5 are my only factors of 15. So I'm hoping I don't have to arrange these in a 15 by 1 rectangle. But the 3 by 5 rectangle should work. Now, the only way to get a negative here is to have positive times negative. Okay, so one of these regions are going to have to be all green, one of these regions are going to have to be all red. And right now I just have this, all right, so there's no way for me to make a rectangle. But what I'm able to start doing then is adding some 0 pairs. All right, if I were to start adding in 0 pairs, then I have a possibility of getting somewhere. Okay, let me add in another 0 pair. Right, because I can't change the value of my problem. The only way to not change the value of the x squared plus 2x minus 15 is to add 0. And notice if I start adding in 0 pairs, this looks promising. I'm always going to have more green than I have red. Okay, so the green's going to have to go this way. There we go, and the red can go this way. Okay, so I have shown now that this factors into x plus 5, right? X plus 5 this way, x minus 3 this way. Okay, next example, and then I'm going to hope that you will play around on your own. Make up some of your own examples and just play around. Okay, in this next example, I have, let's see, minus 8x. So I have 8, and then I need 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I hope I don't have to arrange in a 1 by 12, but then I don't know, do I want a 3 by 4 or do I want a 2 by 6? All right, so I arrange these, and the only way I get positive is to either multiply positive by positive, which I obviously can't do, or negative times a negative. Okay, so I try to arrange these. So our 3 and 4 going to work, and so close, but no. Right, so notice I do not have a rectangle. Okay, so 3 and 4 are not the factors that will work. So then I try a different set of factors. How about 2 and 6? How about I arrange the 1s into 2 and 6? That lets me make a perfect rectangle, and I can see that this factors into x minus 2 up here, x minus 6 going this way. Okay, so I encourage you to make up some of your own examples and just play around. I think this is tons of fun. Again, this would be best for your concrete learners. All right, now moving on down here, what if the a term is not 1? This would still work. Okay, 3x squared. So I've got 3x squared. The only way I can arrange 3x is a 3 and a 1. And then I would have 5x positive. And then I start here. Okay, so the only way I can arrange the 2 is 2 and 1, right? And then this has 3 by 1. And then I place these in, and I can see that this would factor into 3x plus 2 going across the top, and then an x plus 1 going the other direction. Okay, so this gets a little sticky. I remember last year doing this in class and, you know, having to stop and help some of the students in the class with this. So certainly if I have to help 302 students, this may not be real easy to be doing with students that would be in about 9th grade. I think you would be doing this. So anyway, let's take a look at this problem, which is the 2x minus 3. Now remember, the only way to get to a negative here is to have negatives here, positives here, or vice versa. Okay, because if I try to arrange right now, gosh, it's so tempting to think that that works, but then this would give me negative times negative, which is positive. Right? It's tempting to think that that works, but it doesn't. Okay, so what can I do? I have to somehow arrange these so that I get let's see. I just forgot how to work this one. Hang on, let me cheat and do the problem. Minus 3 plus 1. So I would have to have 2x plus 1. There we go. I'm going to need to add 1 0 pair. Right? 1 0 pair in. There we go. Like I said, hard problem, right? I just had that moment of panic where I wasn't sure what to do. So that would go that way. Okay, 2x plus 1, x minus 3. Okay, so I have my positive times my negative to give me my negative. Okay, so it would be easy to struggle. I almost struggled there too. Now this one is definitely very challenging. With the 4, I don't know if I need to arrange that as 4 by 1. Or I could do 2 by 2, right? Not sure what's going to work. And then with the positive 10, I'm going to start by trying a 2 by 2 arrangement with a 2 by 5 for the 10. And I've got minus 13 for my x's. 2, 3, 4. 10. Uh-oh, I need 2 more. Oh no. All right, run and get me 2 more, Jay. They're in the living room. Okay. So, let's see if this works. Let's see, this would give me 10 of them. Going this way.
I got you back.
Oh, you have to get me all the same ones. My lovely assistant here who is helping me out. And how many did I say I was short? I was short 3. Not going to work because I'm going to need 4 here. So that's not going to work. So I might try then instead the 4 by 1 arrangement. Okay, so 4 by 1. So let's see, is this going to work for 13 of them? I would have 5 here. Aha, this is going to work, right? Because I would put 5 here. And then have to have 13, 5, 6, 7, 8, 9, 10, 11, 12, and 13. And this worked. All right, so there's my 4x plus 5 with my minus 5, sorry. 4x minus 5 with my x minus 2.